Alright, what up everyone? Let's get going on this mod review. Here we go. So converting the angle measure here from degree to radian, main idea here to remember is that 180 degrees equals pi radian, and the reason why is that pi radian is half a circle, and pi radian is half a circle, 180 degrees, also half a circle, they're the same thing. So anytime you're doing this, you're going to want to go ahead and multiply by pi and divide by 180 degrees. Likewise, if you're converting from radian to degrees the other way around, like here, you'll multiply by 180 and divide by pi. Let's go ahead and do it. So multiplying by pi, dividing by 180, our zeros are going to cancel. 22 over 18 reduces to 11 over 9 pi. Kind of just do this for all of them, honestly. Really not a big deal. Multiply by pi, divide by 180. Divide both the top and bottom by 30 to make this 11 pi divided by 6. There's your reducing right there. Not too big a deal. If you're having trouble seeing that, put these over 1, you know? Just do some cross-canceling like you would do back in the day. For negative 80, we'll go ahead and multiply again by pi, divide by 180 degrees. Both of those are divisible by 20, and therefore you're going to go ahead and get negative 4 pi divided by 9, and 0 degrees is 0 radian. Not really even a big deal of multiplying by anything. Next one, number 5. If we multiply negative 4 over 5 pi multiplied by 180 over pi radian, the pi's are going to cancel. 180 divided by 5, well, that's going to be 36. 36 multiplied by negative 4 is negative 144 degrees. Please note on this test, if you really need a calculator, you're only allowed to use one of those little baby calculators from the dollar store. Can't even have sine and cosine on it. So might need some help reducing these things and make sure they are good to go. Anyways, 3 pi, 3 over 10 pi radian, multiply by pi, multiply by 180, divide by pi. Sorry about that, said it backwards. Zeros cancel, and we have 18 times 3 is 54 degrees. 5 pi over 4 radian. Yet again, same thing we've been doing. Multiply by 180, divide by pi. There's really not much to these. You do this out. 180 over 4 is going to be, what is that going to be? 45. 45 times 5 is 225 degrees. And negative 7 pi over 9 radian. Multiply by 180, divide by pi. Pi's cancel again. 180 over 9 is 20, multiplied by negative 7, negative 140 degrees. Really not much to these. Starting off number 9, all of these next guys are going to use one of our key formulas we've been doing in class for quite a while. S equals R times theta, which basically means the arc length subtended by an angle of theta radians is going to be the radius multiplied by the angle, and again this has to be in radian every single time. So it says here it measures 3.5 radians. It is 20 inches for the radius. So in this problem we just have 20 multiplied 20 is the radius and 3.5 is the angle measure, and that's going to give us an arc length of, what is it going to be, 70 inches is the unit. Make sure you include your units. Don't want to forget those and lose points for no reason. A central angle subtends the circle, and the length of the arc cut off the angle is 30 inches. If the radius is 6 inches, what is the measure of the angle in radians? Well, the arc length is 30 inches. The radius is 6 inches. S equals R theta is what I'm using again, times theta, and we get 5. Radian is theta, and we don't need to put units on radian. There are no units for it. Continuing on, let's move on to the next page. A circle with radius 10 inches subtended by an angle measure of 35 degrees. So that S equals R theta, which is what we're going to use again, only works if you're current angle measure is in radians. So we have to take this 35 degrees, and looks like we were doing on the front page, multiply by pi, divide by 180. And when you do that, dividing both top and bottom by 5 to reduce, you're going to end up getting a little bit of work here. Divide by 5, and you'll get 7 pi on the top. And on the bottom, divide by 5, you'll get 36. So 7 pi over 36 is our angle measure, and we have to multiply that by the radius. So S equals 10, the radius up there, multiplied by pi divided by 36. Doing this, looks like we have 10 over 36 reduces to 5 and 18 here, and our final answer is 35 pi divided by 18. Not too terrible. Oh, and it's inches. Right? Yes. Inches. Boom, boom, boom. What does it mean for an angle to have a measure of 2 radians? It means that the arc length cut off, and the word we want to use here is subtended. Subtended is the cutoff part, or the arc length created by the angle swept out is 2 radius lengths. That's the idea here. So that's what a radian is. A radian is saying that our angle in between is 2 radius lengths. So here's our radius, and if we were to cut off that part, we're saying that this length right here is 1 radian, and for 2, well, we need another radian right here. So this overall angle from here to here is what we are looking for, is that guy. Having a little picture right there would definitely help you towards getting full credit. What does it mean for an angle to have a measure of 100 degrees? Well, 100 degrees, every single degree is 1/360th of a circle. So 1 degree equals 1 over 360 of a circle. Likewise, if you wanted to find a radian like this, you could say 1 over 2 pi of a circle. So it just means the angle swept out, is 100 360ths of a circle. That's kind of the definition. It's not really that big a deal. I will accept a lot of different things here as long as it is clear that you have an idea as to what it means. You're not going to be able to divide a circle into 360 parts. It's going to take a little bit of time, but it is 100 degrees up there. So maybe draw a little picture for yourself of what 100 degrees is about right there. There's your 100 degrees. So a bug is sitting on the end of a blade of a fan shown in the diagram below. He sits 1.8 feet from the center of the fan and stays in the same position on the blade as the fan turns. How does this? He does this till he gets dizzy and falls off. How far does the bug travel around the center of the fan when the fan rotates? 4.5 radians. We're using the S equals R theta one more time. So our radius here is this 1.8, and so we got 1.8 multiplied by 4.5, and that is our S value, our arc length. That's how far the bug has traveled. That's going to be this length, whatever it is, and we're talking 4.5 radian. So 4.5 radian is about right there. That's how far he's gone. And the reason why I knew that is because this is pi radian out here. This is 3.14 radian. So 4.5 going to be really close down here to the bottom. The bottom, by the way, is 4.71. Radian, 3 pi over 2 radians. Anyways, multiplying this 1.8 multiplied by 4.5, that's going to be, let's see, 72 and 9 is 81, 8.1. 8.1 feet. And on the test, the units, the numbers are nice whole numbers, you know, stuff like 3, 4, 5, is, you know, it's nice, easy numbers to work with. If the bug travels 18 feet around the center of the fan, how many radians has the fan rotated? So he's gone 18 feet. The current radius is 1.8 times theta. 18 divided by 1.8 is 10 radians. If the fan rotates 120 degrees, how far in the center of the fan will the bug travel? Yet again, we need to go ahead and convert that into radians. So 120 degrees multiplying by pi divided by 180 degrees. And that's going to go ahead, 120 over 180 is 2/3 pi is your angle in radian. And S equals r theta. S equals 1.8 times 2 pi over 3. And honestly, just leave it like that. I'd give full credit for this. Just leave it. No need for anything crazy. Write an expression represents the bug's vertical distance in radius lengths above the horizontal diameter. So if we are in radius lengths, it's kind of implying that the radius equals 1. And the vertical distance is quite simple. We'll write f of theta equals sine of theta. That is the definition of our vertical distance. Really not too much. Whereas if the bug's vertical distance is measured in feet, oh, almost fallen off the page. I am so sorry, guys. I messed that one up. F of theta, sine of theta, radius is 1. I didn't scroll down. Hopefully you're able to listen and not just watch it without sound. Oof. Anyways, write an expression to represent the bug's vertical distance in feet above the horizontal diameter. State the value of this expression. And I don't know what it means. State a value of this expression. I gotta read this really quick. What is the value? Maybe they're saying for this letter C question, so they really were trying to do like sine of 2 pi over 3. And that was a good enough version of it. Remember, if you want to approximate that, we can do a little drawing. I'm going to explain the approximation for this later, but for right now, you can know that that's 0.866 is the value of that guy. We'll learn how to approximate that. I would take 0.9 or 0.8 as a good approximation, but I'm more worried about this value, honestly. Just leaving it there will give you full credit. Write an expression to represent the bug's vertical distance in feet. Now the radius is no longer 1. The radius is 1.8 like we said earlier, so maybe g of theta is going to be 1.8 times the sine of theta. And that's going to be 1.8 times the sine of 2 pi over 3. And I do not feel like multiplying this out and trying to make a good guess of this. It's just not a great use of time. I mean, I guess I can, though. 0.9 times 1.8 is about 1.7-ish, approximately. All right, let's go to the next one. Let's write an expression here, represent the bug's horizontal distance in radius lengths. The horizontal distance in radius lengths is going to be cosine, so maybe f of theta equals the cosine of theta, and again, we are looking for the cosine of 2 pi over 3, which if you approximate it, actually ends up being exactly 1/2, or 0.5. And in feet, well, now we have a different radius again. The radius is 1.8, so 1.8 times the cosine of 2 pi over 3, and that ends up being exactly 0.9. So write an expression here. We already did that. State the amplitude, period, and midline of each of the following trig equations, then draw a graph of the function. So for these problems, we have to remember our main formula that works for both sine and cosine. F of theta is always going to be equal to a times the sine of b times theta plus d. And please note, I'm just using theta here as some angle measure that's going to be in radius lengths. So a in this problem is going to be our amplitude, or radius. And please note, this is always a positive number every single time, even though like over on the next problem down here, it appears to be a negative number. It's actually not a negative number. It's just that positive value. We're going to deal with that negative in just a second. In addition, for this letter D out here, that's going to be our midline or our center line. Midline, center line, average, whatever you want to call it. A lot of different names for it. And the letter B in front up here, I give it the name the period changer. And the reason why it's called the period changer here is there's a formula you kind of want to get down pat. The period, which is one full cycle, one hump up, one hump down, a top to a top, a bottom to a bottom, is always equal to 2 pi divided by the b value. So we kind of want to have this little formula of ours just memorized down pat. In addition to a little memorization of this before I start the problem, we want to have a nice little picture memorized of sorts. So we're going to put a positive sine graph right here. We did a chart like this for, we did a chart like this when we did the square root functions and things like it, and we're going to do the same exact thing. So positive sine here, I'm going to go ahead and put positive cosine right here, negative sine right here, and negative cosine right here. So each and every one of these is going to have 5 key coordinates that are going to be evenly spaced that we're going to want to deal with into 4 equal sections. So these 5 coordinates are going to look like this. For sine, you're going to have 3 coordinates that go through the midline, 1 coordinate above in the middle, and 1 coordinate below, and create the wave. So sine starts in the middle, has the hump up and the hump down. Negative sine is super similar. 3 coordinates in the middle, but then it starts at the bottom and goes up instead. Easy enough. Positive cosine, because it is no longer the vertical distance, sine is the vertical distance on a function. You know, you're thinking about the up and down distance from this value 0 out here. You're going up and down for sine, which is why it starts off in the middle. Cosine instead is the horizontal distance. So the cosine starts at positive 1. So it starts at the top and ends at the top. Their values that go through the midline are actually the ones not quite smack dab in the center, but in between the two. And it goes at the bottom in the middle. And it creates this little guy. Negative cosine starts at the bottom, ends at the bottom, has a guy at the top up here in the middle, and the other 2 points right smack dab in the center. To help us better understand this, there's a cool little GIF online, or a GIF online, that you can see. So I already have that up on my computer. I'm going to go ahead and switch the screen over to it. Let's see if I can actually learn how to do this again. So we want to make sure we're doing this window capture. Which color am I doing? Which one? Set this up. And okay. Did it go? Did it make it? It did. All right, so concept here is that every single time, what you're looking at here is the sine and cosine graph as that little dot goes around the circle. So the sine function, boom, right there, starts at the center and moves up. Cosine moves around, and it creates this wave and just goes on and on and on and on. I'm not too worried about it, but if you want to look this up, just go ahead and, it's on Wikipedia actually, on the Wikipedia sine and cosine page. It's a very cool little guy that you can watch and read about. We're just trying to graph these things. So let's actually do it. So we're going to use this guy quite a bit in this chart here. So to graph these, what you want to do as a starting point is to go ahead and mark up where those 5 coordinates are going to go in a certain way by evenly dividing your x-axis up. So 1, 2, 3 is how many coordinates I'm doing. And then 1, 2, 3, 1, 2, 3, 1, 2, 3. And on the test, it specifically says to graph 2 cycles. So I'm going to go ahead and graph the one to the right and the one to the left. 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. All right. After that, we want to do the y-axis, but to do the y-axis, we actually have to fill in this information about amplitude, period, and midline first. So the amplitude of this question is the number in front of the sine, which is an invisible little 1 up there. There's our amplitude. That means it goes up 1 and down 1 from the midline. It means our radius of the problem is 1. Our period is always 2 pi over the b value. In this case, the b value, the number in front of this, is also a little invisible 1, so 2 pi over 1, which is 2 pi. And our midline of this equation is going to be whatever that number is out there, which is 1. So maybe off to the side, a good idea to do is to figure out the top and bottom value of the sine and cosine graph. What I'm talking about is this distance between here and here is the value a. It's how far up and down you're going. So from the midline, which in this problem is positive 1, so we need to put positive 1 somewhere, it's going to have a midline of 1, and it's going to go up 1, the amplitude up to 2, and down 1 on the amplitude to 0. So we want to go down to 0, up to 2. So we need to divide this up to do that nice and neat. I'm going to make 1 right here at this tick mark. I'm going to make 2 up here at this tick mark. I just counted by halves basically. We have a dotted line right through 1. Cool. And now we have to put these 5 coordinates. Like I was trying to say with sine earlier, the first 3 dots here, the first one, it starts in the middle, right on top of that midline. And then the furthest right dot is also on the midline, and this little middle dot's on the midline. Repeat the process on the other 2 sides. Then in between our first 2 that we marked up, our first 2 here, we're going to top out our very top value. So we just figured out that was 2, our midline plus our amplitude. So it's going to go all the way up to 2 here. And likewise, it's going to go down 1, down to 0. Repeat the process over here. So we have all the way up to 2, down to 0. We can actually draw our wave in now. Finally, we actually have to mark up our x-axis. We haven't done that at all, and we're going to use our period to do that. So the furthest right-hand value over here that we've done is a full up and a full down. That is what a period is. A period is that full up and full down. So we're going to go ahead and mark that guy as 2 pi, and this guy is negative 2 pi. And then this way is exactly halfway in between that, so 2 pi divided by 2 is just pi, half of it, and this guy is negative pi. On the test, it asks you for 5 coordinates, and that's enough. We have 1, 2, 3, 4, 5 marked up, and we can just go ahead and stop. If you want to figure out the other ones in between, you just divide by 2 again. Really not a big deal, but I'm just going to go ahead and stop there because that's all we need for this this guy. Let's do the next one. 2 cosine of 2x. Please note there's an invisible plus 0 out here. That's going to be our midline. Our midline is 0. Specifically y equals 0. If you want to add in that y equals, you could. The amplitude of this problem is 2. It's this number in front. And the period is 2 pi divided by 2. That b value, which is exactly pi. Same exact thing as last time. Let's make up our tick marks nice and easy. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3, 1, 2, 3, 1, 2, 3. Okay, we've done that, and now we need to figure out how high up and down we're going. So our midline is 0, and we're going up 2 from the midline, so up to 2, and we're going down to the midline, down to negative 2. So we've got to make sure we tick this up. So we got 1, and I can count. There's a 2 there. Negative 1 there, negative 2 there, and we can go ahead and start putting stuff in. If you notice, this guy is a cosine, a positive cosine graph, because that's a positive 2 in front. So our positive cosine here, we're going to start at the top. So we're starting at the very top, which we figured out earlier was 2. So we're going to start all the way up here. We're also going to end there for both of these. Right smack dab in the middle of cosine, you go to the very, very bottom. We're going to bottom out at negative 2. Bottom out at negative 2, and we will cross through that midline, the midline of 0, in between these ones. So we'll do there, in between, in between, in between. Go ahead and draw our wave in. Make sure you don't draw like vertical lines. That'd be, not vertical lines, diagonal lines, like straight lines. That'd be very depressing. It's a wave. Make sure you make it a wave. I will definitely take off points if you make it straight lines. It might even be like 0 because I'm so upset. Please don't do that. Alright, so there's our wave going up. Please note, the graph actually does go on forever in both directions. We could try to make it go off. We don't have to draw it, though. This was really terrible. It wasn't even a good drawing. But we only need these coordinates written up. And finally, we're going to go ahead and mark up our axes. Remember, the furthest right value that we graphed up is exactly a period, so we're going to put pi out here and negative pi on the other side. And halfway in between that is going to be pi over 2, and therefore this guy is negative pi over 2. Let's continue on. So number 16, that number 3 actually makes the problem really nasty and ugly when you're doing the division up here. So I'm deciding that's not a 3 anymore. It's now a 4. Great. Okay, so I just did that. We will not have a number like 3 on the actual test. It'll be a nice, easy number like 1 or a half or 4 or something like it. Here we go. So the amplitude is positive 2. Please do not put negative 2. Be careful. This is just a negative cosine graph. So this guy over here, this negative cosine. Then the next one, we have our period. Our period is 2 pi divided by 4, which simplifies to pi over 2. And our midline is negative 2. So go ahead and figure out what your biggest value is and your smallest value is. So your midline is negative 2, and you're going up 2 units right here are amplitudes. So you're going all the way up to 0, and you're going all the way down to negative 4. So you got to make sure we get this down to negative 4. So here's negative 1, negative 2, negative 3, and negative 4 is actually off the graph, but that's okay. And then our midline is negative 2. So draw that guy in there. And we never marked up our axes. We got to do 3 nice little tick marks. So 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, and quick little drink break for a second. Oh man. Okay, so we marked up our axis here, nice and easy. Because it is a negative cosine graph, we are going to start at the bottom. So we're starting at the very bottom, which we figured out earlier was negative 4. And we also know that we're going to end at the bottom. We're going to end at this negative 4 value. The very top value we figured out was 0, so that's going to happen exactly halfway in between for negative cosine. And then we're going to go through that midline in the middle of these guys. Yet again, please make sure we draw in this nice and neat wave. Make it actually wavy and not just straight lines. It's like a roller coaster. Wee, wee, wee. All right. Finally, we have to mark up our period. So our period is pi over 2. That means our farthest right value is pi over 2. Our farthest left value is negative pi over 2. And our value in the middle there must be half of that. That's pi over 4, multiplying by a half, and negative pi over 4. All done. Just for variety's sake, I'm going to change problem 17 to, I'm going to put a negative in front of this 3. That way we have to graph a negative sign as well, just because we haven't had to do that yet. So the amplitude in this is still positive 3. Remember that negative in front only changes what this guy is down here, this negative sign. The period here is actually pretty interesting. So you have to remember your formula. Your period is always equal to 2 pi divided by that b value. The b value this time has a pi in it. So it looks scary, but it's actually easy. Use one of your little pre-algebra rules. You have 2 pi multiplied by 3 divided by pi. What I'm saying is the pre-algebra rule is that if you divide by a fraction, you multiply by a reciprocal. Now the pi's cancel, and 2 times 3 is 6. So now our period is actually having no pi's in it at all. Nice. The midline here, again, there's an invisible plus 0. Positive 0. I don't know why I put positive 0. There's no such thing. It's just 0. That's kind of silliness. So again, our maximum value, we're going up 3 units, that amplitude. So we're going all the way up to 3 and down to negative 3. Let's go ahead and mark up this axis then. So there's 1, there's 2, there's 3, negative 1, negative 2, negative 3, 1, 2, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. By the way, you could have done 4 tick marks or 5 tick marks. It really just doesn't matter. I just arbitrarily chose 3 tick marks. 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. All right. And again, that is our midline actually in this problem, our 0 all the way through there, and we're going all the way up to positive 3 and down to negative 3, and it's a negative sine graph. So because it's a negative sine graph, our starting point is on the midline, our ending points are on the midline, and these points right in the middle are also on the midline. And negative sign starts off going down, so we're going to go down to negative 3, and then up to positive 3 over here. And then the same thing over here, down the negative 3, up to positive 3, and draw in our wave. Oop, Oops, that was a mistake. That one was in the wrong spot. That was not a good one. That was an oopsie pie. All right. So finishing this up here, we have to go ahead and make sure we put in our period. Our period is 6. That means this value over here is positive 6. This guy is negative 6, and smack dab in between, positive 3, negative 3. Nice and simple. We're finally done with the graphing page. Let's move on to the next one. Only 2 pages left. So this problem, going backwards. So going backwards, it's a little bit hard to see, so just so it's a little bit easier, I'm going to kind of go over with my pen on this one just so you can really see what we're actually graphing here. We have to do the same process backwards. So or again, every single one of our answers is going to be of the form a times the sine or cosine of bx, actually f of theta. This is to define a function. So f of x, oh boy, f of x or f of theta equals a times sine of bx plus d. And the reason why there's not a plus c, by the way, is because next year in pre-calculus you'll actually be using letter c as a phase shift or a phase angle, but we're not going to deal with that in Algebra 2. Anyways, a is that amplitude. It's the distance from the top and the bottom. Top and the middle, sorry. So the top and the middle here is that value, is that distance. So in this problem it's actually just positive 1. So we have f of x equals 1. I'm just going to put it there, times the sine. And the reason why I knew it was sine is because it starts in the middle and goes up. We again have to keep track of this rule down here, where if you start in the middle and go up, you're positive sine. You start in the middle and go down, you're negative sine. You start at the top, you're positive cosine. Start at the bottom, you're negative cosine. So then we have the sine, and we have to figure out what the b value is. A b value is a full up and a full down, a top to a top, or a bottom to a bottom. One of those 3. So here is a full up and a full down. So there's out to pi. So it turns out it's pi is our period. So we use our formula. Pi equals, period equals 2 pi over b. And to solve this equation, quick little pre-algebra trick, switch the position of the b and the pi, and it will solve the problem. 2 pi over pi, and b equals 2, because the pi's cancel. And our midline, it goes through 2. Done. Let's do the next one over here, this number 19. So number 19, again, we got, how would we do g of, and let's use theta this time instead of x, g of theta equals, and now we need to figure out what's happening. If we notice it's a negative sine graph, it starts in the middle and goes down, so we're going to have a negative in front. What is our amplitude? Our amplitude is the distance from the middle to the bottom. So the distance from the middle to the bottom is 1, 2, 3 tick marks. So that's going to be negative 3 to start off there. Sine, because it starts in the middle and goes down. And this time, we don't even have to really solve for b, because the period, a down and an up here is exactly 2 pi, so there's nothing really to work with. And there's midline is 0, so we're actually done. Easy peasy. Let's look at number 20. So number 20, this one's actually a little bit more interesting. So first of all, our distance from the top down to the middle here is still going to be, looks like, positive 1, so we still don't have to worry about that. And it's a positive cosine graph because it starts at the top. So we're going to go ahead and do h of, I'm going to use x again, h of x equals positive 1 cosine, because we start at the top. Figuring out the b value here is a little bit more interesting because we have to do a little bit of subtraction, because a bottom to a bottom is one of our ways of talking about a period, is from negative 2 pi all the way to positive 2 pi. So to figure out that distance, we have 2 pi minus negative 2 pi, which is 4 pi. And then we're going to go ahead and say that 4 pi equals 2 pi over b. Again, we always got to go ahead and do that. And therefore, we have b equals 2 pi over 4 pi. Switch those positions. Pi's cancel. 2 over 4 is a half. 1/2 x. And then our midline's negative 2. Easy enough. This one, it might not be obvious where the midline is, so let's actually do a little bit of a trick to figure out what the midline is, and remembering that another definition of the midline is the word average. So it has a top of positive 2 and a bottom of negative 4. So the average of those two numbers, 2 plus negative 4 divided by 2, that's negative 2 divided by 2, which is negative 1. So that's our midline. And our midline is -1, and we go all the way up to 2. That's 3 units up there. So we have, how about F, G, H, I, how about a J? J of, and let's just be weird. Let's do J of Z. Why are we using Z? Who knows? You can use whatever letter you want to use. J of Z, and we have a negative sine graph, and it's 3 sine, and we got to figure out our B value. So our B value is going to be 1 down, 1 up isn't 2 pi, so we have no B value. And then -1 we figured out was our midline. Easy peasy. Next up, number 22. Give an accurate estimation of sine of 1.2 and cosine of 5 pi over 4. Draw a picture to explain your reasoning. So on this problem, the sine of 1.2 is asking for the sine of 1.2 radians. So drawing a cute little circle here on a coordinate plane. Remember that these guys imply that the radius is 1, so like that's the coordinate 1, 0 if you wanted to. This would be the coordinate 0, 1. Our radius is 1. Remember that the top up here is pi over 2. The side over here is pi radians. This is like 1.57. This is 3.14. And 1.2 is therefore to be, I don't know, just an estimate, about right there maybe. There is our 1.2 angle measure there of 1.2 radian. And if that's our angle measure of 1.2, sine is the y value up there. So the y value in my mind is just barely less than 1. So I'm going to go ahead and say the sine of 1.2 is approximately equal to 0.9. That would be a good little version of my guess there. Whereas the cosine of 5 pi over 4, so 5 pi over 4 is more than pi. The easiest way to do a question like this, in terms of imagining where this is, I'm going to do it over here. Here's my circle. So 5 pi over 4, to do that, pi over 4 means to divide pi, half a circle, into 4 equal sections. So it's already in 2 equal sections, just on the coordinate plane. Now we're in 4 equal sections. There's 1, 2, 3, 4 equal sections. And 5 pi over 4 is one more of those sections. There you go, this coordinate. So 5 pi over 4 is that angle right there, the angle all the way around from that right-hand side down to that third quadrant. And we need to figure out what this value is. Cosine is the left and right distance. So we're figuring out how far away is that left and right distance. It looks to me about a little bit over half visually. It does turn out, this is a value you end up memorizing later in your pre-calculus and calculus careers. This is approximately -0.707. If you just said -0.7 or -0.8 or -0.6, I would have given you full credit. -1/2, not so much. It's definitely further to the left than that. Yeah, I think that's going to be good enough for me. Let's go to the last page here, this page about this water wheel. So a picture of a water wheel. Power in the 18th century is pictured below. Sketch a graph of the height of the bucket above the water as a function of the angle of rotation of the bucket from 3 o'clock position. So instead of doing that first, I'm going to go ahead and do exactly what I did in that previous page and create the sine function for this thing first. So creating the sine function for this situation first. Measured in radians, height of the buckets. So it's a height of the bucket above the water, so it's a vertical distance, so that directly implies that we're working with the sine function. If we were working with the left and right distance, we'd be working with cosine. So starting with the sine function, let's say we had f of theta is our distance. So f of theta is going to be equal to, and what are we going to be equal to here? Well, our radius is 11, says that in the question, times the sine, and we're just going to be regular old theta because it doesn't say anything special about it. So times the sine of theta, and now we need to figure out what is our midline. So what is our average value up here? What is that midline? Where are we averaging? Well, you might want to say 11, but it's not quite because we're actually 2 feet from the bottom of the water. So our average value here is going to be the distance 11 of the radius plus the distance 2 to the bottom of the ground, or in other words, plus 13. So that's the graph that we have to do. 11 times the sine of theta plus 13. So we're going to bottom out at 2. I'm arbitrarily calling this guy down here 2. And then we need to go all the way up to 13. If I count by threes, I think we'll be somewhat okay here. Because if we count by twos, it'll be 4, 6, 8, 10, 12. Actually, that's okay. That's 14, so it's going to go up to 13, which is halfway in between up here. Oh, no, it's not going to go up to 13. Oh, my gosh. What a disaster. Oof. Oh, man, it's not going up to 13 because there's what's the highest point it's going to get to? It's going 11 up as well. So actually, it's going all the way up to 24. So we need to get all the way up to 24. So we definitely have to go by threes. Okay, sorry if you wrote that in pen. I'm writing in pen too. You have a little bit of a scribble with me. So let's go up by threes. So there's 5, 8, 11, 14, 17, 20, 23. So 24 would be about right there. There's our 24. And our midline, we said, was at 13. So 5, 8. Oh man, this is a really bad graph already because you can't make that a 2 and then have it go by threes. Guys, this is a disaster. I apologize. We're going to have to start over. We're going to go ahead and make our graph start right here. This is the new y-axis. Awesome. The rest of this graph does not count. I'm sorry. We're just going to go ahead and count by threes at the start here. So we have 3, 6, 9, 12, 15, 18, 21, 24. Okay, so we know that our midline's at 11. So let's just draw our midline in. Midline's at 13. We know that. Oh my gosh. I'm getting too tired, guys. It's too late at night. All right, there's our 13 value right there in the middle. And we're going up 11 and down 11 from 13. So we're going to go all the way down to 2 here at the bottom, and we're going to go all the way up to 24 at the top. And again, it's a sine graph. So a sine graph starts here in the middle, and we're going to need to have some evenly spaced out functions. I'm going to count out 4 this time. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Is that actually 4? Yeah. 1, 2, 3, 4. There's our 4 tick marks. So a sine graph, again, the middle values here, and it tops out at 24, it bottoms out at 2, and there is our graph. Sorry that took so long. You can go a little bit further if you wanted to, graph another one, just keep on going, you know, put 4 more tick marks on. Define a function f determines the vertical distance, horizontal distance of to the vertical diameter in feet, measured in radians here for that angle. So now we're doing that horizontal distance, so this immediately means cosine. So that's going to be just 11 times the cosine of theta, and the reasoning behind that is there's no extra plus number here because our left and right values aren't going to change. Finally, define a function g that determines the height of the bucket as a function of the number of feet the bucket is rotated. So now we're talking about the arc length. Remember that the arc length here is always equal to the radius multiplied by the theta value. So theta in this problem is going to be n divided by the radius. The radius in this problem is 11. So it's actually the same thing as this function up here, except our theta is n over 11. H of theta, or h of n is going to be equal to 11 times the sine of n divided by 11 plus 13. And that is the conclusion of our video. Good luck on this last test of the year, guys. And I am done making these videos. So peace out. Last time. No more shout-outs. Have a great rest of your day and weekend and summer coming right around the corner.